Yes, good morning, learners. How are you? I hope you are started studying all the documents posted on your LMS page. Now, today I want to just try to explain to you one of the documents that talks about combining probability with and or at least one. So there are a situation where you want to find a probability of an event that have two outcomes. For example, you are a teacher and you want to find the probability that a student is offering both arts or English. So how do you do that? So I want us to look at it. So now, two events are mutually exclusive if they have no outputs in common. Okay, now when you have when you want to find the probability of an event that involves two outcomes occurring, probability, let's say A and B are any events, and you want to find probability that A or B occur. So the formula is, before you find probability that A occur plus probability that B occur minus probability that A and B occur. This is the formula you will use. So and that means if A and B are mutually exclusive events, then you know that probability of A and B is going to be 0, because two of them cannot occur at the same time. So let's look at this example. Let's take a simple experiment. You have a coin and you have a die. So what we want to find is, we want to find probably that the coin will land heads up, or the number of the die is 5. That's when you throw the two of them together. So what are your possible sample space? For a coin, you can only have head and tail, but for die, you can have number 1 up to 6. So you have 12 possible outcomes for the event. These are the 12 possible outcomes. So using that formula now, probability that head of 5 occur is going to be probability that head occur. So you now count the number of head here: 1, 2, 3, 4, 5. So it's going to give you 6. So it's going to be 6 over 12. Probability that 5 occur. So you count it: 1, 2. So it's going to give you 2 over 12. Then don't forget where the 2 occur at the same time. So you have to remove it. So, and where you look at it, so it's going to be 1 over 12. So probability that head of 5 occur is 7 over 12. So from this formula, when they say probability of event A or B occur, so it's going to be the same thing as probability that event A occur plus probability that event B occur minus probability of both occurring. Now let's look at and. But before we look at let's look at this definition. Two events are independent events if the occurrence of one event has no effect on the probability of the occurrence of the other event. So for example, if I throw a coin now, so if I do it 2 times, the fact that head comes up the first time does not mean head will come up. So they are independent events. So for independent event, if you now say if an event A and B an independent event, then probability that A and B is the same as probability of A multiplied by probability of B. That's the formula. So let's now take this example. Suppose a fair coin is tossed 4 times. What's the probability that all 4 tosses lands head up? All 4. No, I've already told you that these are independent events. So using this formula, so probability that all 4 all the tosses land heads up in 4 trials is going to be probability of the first trial is head, the second trial is head, the third trial is head, and the fourth trial is head. and using the multiplication formula is going to be probability of the first trial is head multiplied by probability that the second trial is head multiplied by the probability that third trial is head multiplied by the probability that fourth trial is head. So half times half times half times is going to 1/16. Now let's look at the last one that I want to treat in this video, where they say at least probability that at least this event occur once. So how do you undo that? Assuming you have an event and you do a trial several times, so they now said what is the probability that so particular outcomes come up at least once. So how do you get that? So let's look at the definition. If an experiment is repeated n times, the n trials are independent and the probability of event A occurring one time is this. Then the probability that A occur at least one time is 1 minus probability the probability that does not occur at all in that numbers of trials. Are you following now? I'm going to show you the an example. There's one example. I want to pick an example to show you. Okay, let's use this one now. Let's assume a multiple choice test consists of 6 questions. Each question has 4 choices, only one of which is correct. A student guesses all 6 questions. What is the probability that he get at least one answer correct? So now what we are going to do now, the probability that he gets one answer correct is 1/4, because he has each of the question have 4 choices. So if he gets, so the probability that he gets one correct. But now let's now assume that this is done, then the probability that it does not get it correct is 1 minus 1/4, which is 3/4. Okay, now in 6 trials from this formula, so the probabilities that at least one is correct in 6 trials is 1 minus probability that is not correct raised to power 6. So you are going to multiply it, so and then you are going to get 0.822. So I want you to read this text, and then if you have any question you can ask. Thank you.